Hey everybody, this is going to be a video on how to draw the Bohr model. Bohr model originated from a guy named Niels Bohr, I think around this guy. He started this model in about 1912, 1913, pretty much early 1900s. That's when there's a lot of movement in the discovery of the structure of the atom. So they discovered the proton, the electron, and the neutron, and they have to come up with a model that best accurately showcases the atom. So Niels Bohr developed this model for simplicity. Well, he sort of mimicked the solar system. How it works is that there's the sun and your planets revolve around the sun. Your atoms are similar to that sense, and they have sort of your orbits. That's why we draw rings around it. So whenever you draw a Bohr model, you want to start off with your nucleus. And to start off, we're going to use fluorine. Fluorine has an atomic number of 9. So this one, atomic number is down here. It has an atomic number of 9. So atomic number of 9. This atomic number can tell you a couple things. It can tell you the number of protons, which is exactly the same, and also the number of electrons, which is exactly the same. To start off, we're going to draw the nucleus, which is in the middle. So we're just going to say P for protons, and we have 9, and electrons, we have, oh, I'm not drawing the electrons. I'm going to draw the neutrons here. How we find the number of neutrons is actually just taking the atomic mass, which in this sort of periodic table is rounded up to 19. So it's 19, and you're going to subtract the atomic number, and which gives you 10. Sometimes, most of the time in the earlier elements, you would have the same number of neutrons as your protons, but as you get bigger, the masses get bigger, so your neutrons will actually be different. So I'm just going to write 10 in the nucleus. So this is my nucleus, and I'm going to draw a couple of rings. And this all these rings are your orbits and where the electrons are. So for Niels Bohr, he basically suggested that these electrons are in these orbits and they cannot sort of move away, and they're kept together by this electrostatic force, like the negatives and the positives. And the next step here is to draw your electrons. So you have to follow this 2-8-8 rule. And this Niels Bohr model really just works for the simpler, smaller atoms. As you go down, it's pretty much very difficult to draw the Bohr model for big elements. So 2-8-8 rule will work best for the first 3 periods of your periodic table. So what this 2-8-8 rule means that on your first shell you can only have maximum of 2 electrons. Second shell you can have maximum of 8, and then the last one you can have a maximum of 8. So for fluorine, since we decided and we have calculated that there are 9 electrons, we're just going to fill this in. We're going to have 1 here, 1 here. I always like to do opposites, so just to it's easier to see, and I always do it in your 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock, because then you can see the pairing instead of just randomly put your electrons. So I have 2, and I'm going to draw another one. So I have 1, 2. I'm going to fill in these 4 sides first. So that's 4, 5, 6, and then 7, 8, and 9. So that's your Bohr model. Simple as that. You have your nucleus, you have your 9 electrons. And whenever people ask you about your valence electrons, I always forget what this is. Valence electrons are the electrons on the outside shell. So everything on the outside ring, these are your valence electrons. So how many do I have on the outside? I have 1, 2, 3, 4, 5, 6, 7. So valence electrons, I have 7 electrons. And that's it for a Bohr model. One key thing about Bohr model is that the importance of it is for you to see when you start to do some combinations or forming bonds, it's important to think about valence electrons, because it's all the bonding happens on the outside ring or outside orbit. So since this one has 7, all atoms would like to achieve 8 electrons on the outside ring. So this one has 7, it's missing 1, and it's more likely to want 1. So I'll talk more about that in the next video, but this is just the basics of the Bohr model. So hopefully you got something from the Bohr model. Hopefully this helps.